Find the absolute extrema. Values of f of x equal to 5x to the 4/3. From negative 27, less than or equal to x, less than or equal to 8. Now, if they ask for maximum min or absolute extremas, and they give you a range of values, then you got to check the endpoints and the critical value. Okay. So first step is, so step 1, find f prime. So the derivative would be 5 times 4/3 times x, and then you do 4/3 minus 1. So that will be 20/3 x to the 1/3, right? Okay. Step 2, find the critical values. So in order to do so, you set the derivative equal to 0. So you're going to get 20/3 x to the 1/3 equal to 0. And when you do your algebra, of course, the only way that will be 0 is if x is 0. Right? Plugging in 0 here gives me a 0. If you want to do the algebra, you're going to get this. So there's my critical value. So step 3, plug in x equals negative 27, 8, and 0, and determine what is the minimum / max. So here we go. So f of negative 27 is equal to 5 times negative 27 to the 4/3. So that will be 5 times the cube root of negative 27. That's going to be 3, negative 3 to the 4th power. That will be 3 times 3 is 9, times 3 is 27, times 3. I think that's 81. Let's get our calculator out. Count 5. Let's check. So 5 times negative 3 to the 4. 405. Okay. Now let's do f of 8. So that will be 5 times 8 to the, what is that? 4/3. That would be 5 times 2 to the 4th, which is 2 times 2 is 4, times 2 is 8, times 2 is 16, 16 times 5, 80. Now f of 0 is 0. So maximum at is going to be at negative 27, 405. Minimum is at 0, 0. And these points came from the endpoints. This came from your critical value. If you had more than one critical value, you would have to test all of them and the endpoints. Any questions on number 1? Does step 1, 2, and 3 make sense?
time shaving my
Right. Let me know if there's anything you don't understand. Let me know. Let's look at the next couple of questions on your review. Can you see the review? So there's B for the one we just found, right? We said minimum at 0, 0, 405 when x is negative 27 maximum. 2 is the same deal. It's just a sine function instead of a power function. That's the only difference. Number 3 says find critical values. That's all they asked for. So let's see. Let's do it. Find the critical value of f of x equal to negative 6x values. X plus 2. All right. So this is question 3 on your review. Determine all critical points. Okay. So we're going to have to do a derivative, right? So step 1, find f prime. So that will require a quotient rule. So square the bottom. And I think it's derivative of the top times the bottom minus derivative of the bottom times the top. Let me double check. Yeah, derivative of the top times the bottom minus derivative of the bottom. Yeah, we're good. I'll move the denominator though, because it looks weird. Okay. So the derivative will be negative 6 times x plus 2 minus derivative of this guy would be a 1, just a 1. That'll be negative 6x minus 12 plus 6x over x plus 2 squared. So this will be negative 12 over x plus 2 squared, right? These negative, this x, 6x's will cancel. So you're left with this. Okay. Step 2. Set f prime equal to 0. As you can see, or hopefully you can see, that this will never be 0. This has no solution. Therefore, 3 dots means therefore, there are no critical points. There is another scenario where you could have a critical point. If the undefined value does not exist in the original, but it exists in this derivative, then it is then it is considered to be a critical point. So right here we have the same division by 0, right? So that means it's not defined here, so and it's not defined there, so it doesn't count. But if it was x plus 2, if there was an asymptote here only in the second part, then we would say there's a critical value at -2. But that's not the case here. So no critical value, so you would just say there's none for question 3. But you need to make sure you show your work, right? I'm only looking at the work. I don't really care if you choose the wrong answer. I want to see that you worked it out. That's cool on number 3. All right. Let's look at the questions again. So 3 and 4 are very similar. They just say find the critical values. I told you we're not gonna worry about number 5. So if you make a note of it, if you see any question with mean value theorem, just go ahead and skip it. If you show all your work and do it, then I'll give you extra credit, but if you don't do it, I'll just give you the points it's worth, okay? Number 6. Determine the intervals where it's increasing or decreasing. So here they already gave us the derivative, so make sure you notice that. So f prime is this. Right? This is number 6. Using the derivative, find the intervals for increasing / decreasing. The derivative that was given is x to the 1/3 times x minus 6. So since you already have that, step 1 is set this to 0. So x to the 1/3 times x minus 6 equals 0. Set each part to 0. This means that x is 0 and x is 6 for my critical values. So step 2 is find the critical values by doing this. Step 2, use the first derivative test to find the intervals of increasing / decreasing. So you plug numbers below the critical value right here. I'm going to choose -1, 1, 7, I guess. See what we get. F prime of -1 would be -1 to the 1/3 times -1 minus 6. This would be -1 times -7, which is positive. So we're increasing up until here. The derivative at 1 would be 1 to the 1/3 times 1 minus 6, which would be 1 times -5. This is negative. Now what happens at 6? Oh, sorry, at 7. Plug it in, that'll be positive 7 times 7 minus 6, which would be a positive times a positive. So plus. Okay, so we have increasing. From negative infinity all the way until 0. Increasing after 6. We're decreasing only in the middle. 0 to 6. Any questions on finding these intervals? Okay. Yeah, so you should have a question just like this where they give you the derivative and then you use the first derivative test. It's a little easier. Saves you like a step. Sharing the right screen. So number 6, number 7. Determine the open intervals on which the graph is concave down. Okay. So here you have to take 2 derivatives and plug in the critical values. Interesting. So 6, 7 is very similar to 6, but let's go ahead and do it. Determine the intervals where the function is concave down. Function they give me is this guy. You could do a quotient rule if you want, or you could do a forced chain rule. I don't really care how you do it. This is what I'm thinking. Is to change it into this. And just do a chain rule. So the derivative would be negative 28 times x squared plus 3 minus 1 times the derivative of the inside. Do it again, and you'll have a quadratic rule. So derivative of the first, 28 times 2, what is that? 56, right? Let's go ahead and show it in steps. this derivative times this plus oops. Derivative of, damn it, this guy. So this derivative right here would be 56 times x squared plus 3 minus 3 times 2x times 2x again plus it'd be minus, right? 28 x squared plus 3 minus 2 times derivative of that would be 2. Okay, and if you want to do quotient rule twice instead, you can. If you don't like this, I just decided to do it for no reason. 2x times 2x is 4x squared times that. 56 times 4 is that? I'm getting tired here. Let's just multiply it out. That'll be 224 x squared minus 56 times x squared plus 3. Okay. Looks pretty gross. Let's factor. I'm wondering if quotient would have been, well, not easier, but prettier. This is kind of funky looking. So let's factor -2 out of both. 224 divided by 56 goes in, right? 4 times. So you can factor 56 out of both and x squared plus 3 to the -2. So if I factor this out of both of them, if you're factoring a negative exponent, it's as if you're adding to the powers, or minus 2. So we'll end up with 4x squared times x squared plus 3, so -1, minus 1. Okay. So I got the second derivative, not the first one. So step 1, I kind of forgot to write the steps here. I carried away here. Step 1 is find f prime and f double prime. That's what we just did. Step 2 is set f prime to 0 and find critical points or numbers. Step 3 is plug in the critical into f double prime. So this is all we're really doing. 3 things. It's just that the derivative is a little nasty on this particular example. Okay. All right. So step 2, f prime equal to 0 would be this garbage right here. So x would be, weird. X would have to equal 0. That would be my only critical that I see. Same thing for you know what, let's graph this. Something strange here. So we have this critical value here. The answer is supposed to be from 1 to -1. So I think, because using step 2, usually this works, but it's not working right now because the critical is 0. Plugging that into the second derivative would just make it 0. Would tell me that it's concave down. Well, let's keep going. Maybe it'll work out. We'll see. It's just a strange question. So we said on step 3, plug in the critical value, right? This is pretty weird looking. I haven't made it any prettier yet, just because I don't want to. Since I'm going to plug in 0 anyway. Let me make some space. So this will be 56 over 3 squared times, this will be 0, -1. So it is negative. Value doesn't matter. So it's telling me that we're concave down here. So at 0, we're doing this, right? But it wants to know where is it concave down. So I know it's concave down here, but from where to where? So we need to find inflection points. That's the step we haven't done. I'm out of space. Dang it. So let's take this garbage, set it equal to 0, and solve for x. That's what we're going to have to do. Damn. Okay. 56 times x squared plus 3 to the negative 2 times 4x squared times x squared plus 3 to the negative 1 minus 1. Let's set this to 0. So this will be step 4. So solve for x. So it's already factored nicely. So what we will do is set this guy to 0 and set this guy to 0 and deal with this nasty algebra. This has no solution, because if you notice, this will never have a value that makes it 0. So don't worry about it. All we got to worry about is this guy. Let's move the 1 over. Oh, actually, these are factors too. No, wait. No, never mind. No, we're good. All right, so let's see what we can do here. This is freaking weird already. So I'm going to multiply that over here. Subtract the x squared. Divide by 3. Square root both sides, and we get plus or minus 1. So yeah, it works out. I'm thinking I made it harder here. I was being lazy. Well, it doesn't look lazy at all, right? It's actually more complex. I thought this would be simpler. Forcing a chain rule instead of doing a quotient. If I would have done the quotient, the algebra would have been a little automatically factored for me. So I wouldn't have to put much thought into this step. So everything is good. I just advise that use quotient rule here. And when you get to step 4, you'll have a prettier version of this. And once you find this guy, oops, weird. You're pretty much good. So we have 2 inflection points. At x equals 1 and x equals -1. So we're concave down until these points. We change concavity. So the question asks, where are you concave down? Well, it's going to be between. Like the picture. See, it's concave down until 1, and it starts opening upward right after. Right after. Does that make sense? I know the algebra was weird, but the concept okay? We move on to L'Hopital's rule, number 9. We say whenever you have a indeterminate form, meaning if you take the limit and you have infinity over infinity or 0 over 0, you do L'Hopital's rule. And we said if the power is bigger in the bottom, well, the limit will go to 0. But to show the actual L'Hopital step, you got to use derivatives. So this is question step 4, not number 4. Question number 9. Find the limit using L'Hopital's rule.
Didn't the question say without using?
Oh, you're right. You're right. Without using. Thank you. I always do that. I skim it too much. Then I get in trouble. Find the limit without L'Hopital's. Okay. I mean, technically, if you want to explain why the limit is 0, then you could. But if you want to show the work, what you're supposed to do is divide everything by the largest power and take the limit individually. So basically you take the top part divided by the highest power, which is x squared in this example. The next term by x squared. This term by x squared. This guy by x squared. And then you take your limit. But let's reduce it so you can see it better. So this will become 3 over x plus 6 over x squared over 7 plus 7 over x minus 7 over x squared. So when you take the limit, you should see that this goes to 0, this goes to 0, this goes to 0. So you end up with 0 over 7, which is 0. So that's all you need to do. If you prefer to explain that the denominator is growing faster than the numerator, which will mean the fraction will go to 0, then that's fine too. I don't care. Just explain it properly or use this here, this approach. Any questions on number 9? Okay. Let me know. Number 10. given y equal to 2x cubed minus 3x squared minus 12x, find intercepts, asymptotes if they exist, local extrema, concavity, and inflection points. So they're asking for quite a bit. Let's start with the intercepts, I guess. Find x and y intercept. So for x intercept, let y equal to 0. So we get 0 equal to 2x cubed minus 3x squared minus 12x. Factor 2x from everything. That'll get us to here. Wait a second. No, I can't factor 2. I mean, you could, but it would be weird. So factoring that x would be x cubed, 2x squared minus 3x minus 12. Okay. That means that x equals 0 and 2x squared minus 3x minus 12 equals 0. So you got to do trial error or quadratic formula either way. I think AC might work. 2 times negative 12 is negative 24. Sum of the factors will be here. All right. Yeah, it looks like 8 and 3 would work, but you want the 8 to be negative. No, it would not be negative 3. What else works? 6 and 4 doesn't work. Nope. Okay. 12 and 2 doesn't work because these add up to 5 and negative 5. 4 and 6 would be 2 and negative 2. Not what I want. Make sure I wrote everything right. Yeah. Okay. Yeah, I don't think it factors pretty. Lame. One moment. So what they want us to do basically is to sketch the graph using all this information. I'm not gonna require the asymptotes. I'm just gonna require to find the critical numbers, extrema, and then just give me a sketch. That's good enough. You can verify with your calculator, just graph it. If you're using a graphing calculator. To save some time, you would have to use quadratic formula to get x equal to -1.8 and x equal to 3.3. It'll be a square root number. To find the y-intercept, let x equal 0. So that would give us y equal to 2 times 0 minus 3 times 0 minus 12 times 0. So y is 0. So we have intercepts at 0, 0, -1.8, 0, 3.3, 0. No, excuse me. Okay. So those are the intercepts. There is no asymptotes because this is a polynomial, not a rational. So we need extrema, concavity, and flexion. Step 2, find f prime and f double prime. So f prime would simply be 3x 6x squared minus 6x minus 12. Second derivative would be 12x minus 6. Step 3, set the derivative equal to 0 to find the criticals. Okay, so here we go. So this would be x squared minus x minus 2. So that would factor into x minus 2, x plus 1. So critical values would be coming from here. So x is 2, x is -1. So here are the critical values they wanted. Step 3 or 4, set the double derivative equal to 0. So that would be 12x minus 6 equal to 0. So 12x equals 6, so x would be 1/2. So this is the inflection. These are the criticals. Okay. So we got everything they asked for. So now we need to plot it. Oh, we need the extrema. That's what we need to do. So step 5. Find the extrema. So the easiest way is to plug it into the second derivative. So second derivative at each critical point, which was 2 and -1. 2 equals something, and -1. The function was 12x minus 6. So we have concave up, concave down. Concave up means minimum at 2, maximum at -1. To find this value, though, you have to plug it into the original. So f at -1 would equal 2 times 1 cubed minus 3 times 1 squared minus 12 times 1. Negative. So that would be negative minus 3 times positive, negative, negative. So -2 minus 3 plus 12. Positive, right? Yeah. Then I'll do the same thing for 2. Gotta be 2 times 2 cubed minus 3 times 2 squared minus 12 times 2. So that would be what? 16 minus 12 minus 24. Which is -20. All right, so I have all the information, finally. So at that point, you just graph it. Just do your best. Remember, we said we have inflection point at 0, right? We have a intercept at 0 and -1.8 and 3.3. Which is about here. So here are the intercepts. And we know we have a maximum at 2, -20. So down here at -20. And we have this going on. Over here, we're going this way up until like 7, which is going to say about there. Then come back down through that 0. So it looks something like this using the idea of max and min right there, intercepts, and inflection. So putting all together, you should be able to sketch a pretty good approximation. Okay. And if you graph it, this is what I graphed earlier. It looks like this. So pretty close, right? So on an exam, what I want you to do is use your derivatives, find the max and mins, and sketch the graph. You may need to find intercepts for a question like this. It'll probably only be one of these because they're kind of long, as you can see. This number 10 just takes forever. Okay. Let's look at 11. I'm just gonna copy paste this. So picture rolling up a rectangle into a cone, or sorry, a tube. All right. All right, so I'm going to draw the picture. I already posted the thing they talked about in the chat. It's X and Y, and they have some tube thing. Can't draw worth a damn, but here we go. So they rolled this up this way, which means that the circumference would be X, right? Oh, actually, they told us that. So the circumference equals X. So that means that X is equal to two pi r, right? Let me see. Yeah, it is. Okay. Which means, sorry, I already forgot what they asked. Okay. Rectangular sheet has a perimeter of 27 centimeters. Okay, and they rolled into a cylinder. What values of X and Y give you the largest volume? So we need the volume of a cylinder. Okay. The other thing is we know that the perimeter, P for a rectangle, is 2x plus 2y, right? And they said that that's equal to 27. Now we need the volume of the cylinder, which I believe would be the area of the circle times the height. So let's double check. Yeah. Volume of a cylinder would be the circumference squared, the area of the circle, sorry, times your height, which in this case would be 2 pi r squared y. Right. Now we got all the information here. So we need everything in terms of x's and y's. So what we could do, let's call this 1, 2, 3, 4. use 1 to solve for r. So that would give us r equal to 2 pi divided by, sorry, x divided by 2 pi. Right? Divide both sides by 2 pi, gets you to here. No more radius stuff. Use 2, or sorry, 3 to solve for y. So essentially what I'm doing is getting everything in terms of x. You see what I mean? Okay, so now we can change volume, that is in terms of 2 pi r squared y, into 2 pi times x over 2 pi squared times y, which is this weirdness. Notice how everything is in terms of x now. So let's make this pretty first before we go any further. Combine all this nonsense. I'm gonna have to go to the next page, but this will be 2 pi times x squared over 4. Well, actually, we could divide it this way. 2 pi squared. Right? So one of these will cancel that. Which will get us to here. The next page. Let me rewrite what I just wrote. Yeah. So this is V. To multiply this out, this would be 27x squared. Just multiplying the top part. Minus 2x cubed over 4 pi. That's my volume. So finally, we're at a place where we can maximize. Okay, they want to find largest volume. So in order to find the maximum volume, you have to take a derivative and set it to 0. So the derivative of V would equal to 2 times 27, that'd be 54x minus 6x squared over 4 pi. So write this step. Find V prime and set it to 0. That's what we're doing. So 54x minus 6x squared over 4 pi equal to 0. Now, the only thing that really matters here is the top part. what makes that 0? Because this is just a number down here, doesn't matter. You can multiply both sides and cancel it. So when is this 0? So divided by 6. Yeah, factor 6. That'll make this a 9x. Actually, so x is equal to 0. 9 minus x is equal to 0. So x is equal to 9. So 9 is the dimension for x in order to maximize volume, but we still need a y. Earlier, we said y was this. So plug in the x here and you'll get the y. So y is equal to 27 minus 2x over 2. Plug in the y, that'll be minus 2 times 9 over 2, which is 27 minus 18. What is that? That was 9/2. Yeah. So maximum volume happens when x is 9 and y is 9/2. So this one's a little involved. Let's see. So that's how they get this. Okay, so sum it all up, keep it simple. Because right now I feel like it became complicated. Is you find the volume, or figure out the volume formula, get it all in terms of one variable, take your derivative, set it to 0, and find your x. Plug in the x into another equation to find the y. So we had to use the perimeter formula, the circumference formula, and the volume for a cylinder. We put that all together to get it into a one-dimensional problem and solved for x and y. So you'll have one word problem. I don't know. It won't be exactly the same. It might be completely different shapes or something. I don't know. So this is an optimization problem. Is there any questions on 11? All right. Show you one last thing. Is getting, but it's a lot of stuff already for you guys. 13, 14, and 15. Don't worry about these. If you see anything about differential or linear stuff, just go ahead and skip it. We're not going to cover this part here. Newton's method, that's the last thing we did. So I'll leave that to you guys. And we'll stop here. So let's pick a date for this test. Okay. So we are on, this is November 1st. Okay. Okay, that's what we're gonna do. I'm gonna make it for. Let me give you extra time. That doesn't mean wait till the last minute. That means pick a day that works best for you, right? Because I'm gonna move on to chapter 5 next time I see you. So on Thursday, I'm just gonna move on and get chapter 5 done. Chapter 5 will go by pretty quickly, and then we'll do another review, and then you'll have another exam. So technically, this test should be done sooner. So I'd recommend studying this and getting it out of the way as soon as possible, because we're gonna have test 4 pretty quickly. Okay, but if you have a lot going on, you have till the 14th to take the exam and upload your work 30 minutes after finishing your exam, or you will not get any credit. All right. You guys have any questions on the exam